Oh, wait. Hey, hey everyone, my name is Erik Rygg. I work at HashiCorp. I am an enterprise architect, and I'm here to talk to you about service mesh. A lot of people are starting to adopt this technology, and we actually have a tool called Console that provides this as a service mesh, as one of our kind of prime products. So what I want to really talk about, though, is how we got to where we got to this idea of service mesh. We first started with this monolithic application. The monolithic application kind of needed to be broken up into these microservices, and as we started breaking up this, this monolith into microservices, we became aware of many more challenges. So these challenges that we had were things like service identity. Where are our services? How do we access them? How do we route to them? Things like that. So once this happens, we now need to kind of figure out this routing problem. It becomes more and more difficult to route to each service. So as two services communicate with each other, how do we get this identity put together? How do we find our IP addresses? How do we figure out how to get to these services using, we ended up using load balancers. So load balancers got us a great way to get to these, but then we have these load balancers that end up falling apart, right? So at that point, there's now a request that needs to happen in order for our load balancers to actually come online. We lose this agility, and so scaling failures and new services simply just can't come online fast enough. Not to mention, we also have these, where do we find our services, and how do we secure them? So where do services run? What is the IP of that service? How do I talk to it? These are the questions that come up when using these microservices. Scaling up and down provides a set of challenges that really don't come with a monolith. When we have so many services running in heterogeneous environments, the castle walls of our traditional firewalls simply just don't help anymore. So then we start labeling our services. The service instances then register with a central registry. Now as new services scale up or down, they register and deregister themselves, and we kind of have like a more scalable, dynamic environment that we can work with. So, labels, come on, right? So now we can discover these new services immediately, and we no longer have to file a ticket to actually get these services up and running. The next bit is service identity. How do we actually provide the identity to these services, these microservices that we're running? We no longer have these castle walls, so we have to kind of secure this east-west network traffic. The challenge now becomes like, how do you provide identity to these services? How can we build an identity mesh that actually gives us explicit intentions to work with those service-to-service communication? This is where kind of mutual TLS comes into play. And so we also have this kind of idea of zero trust networking. We kind of have to expect that attackers are going to come into an environment. And in that case, a service mesh provides this kind of compatibility layer that allows us to talk between each other, but also explicitly talk between each other. A database and a web may be able to talk to each other, but can they talk to each other? Should they talk to each other? The compatibility is key really to ensuring that the networking silos don't sprout up in different technologies, operating systems, languages, so on and so forth. The next bit is protocol awareness. So here we're talking about layer 7, L7, get it? We also, but even when we don't want, so the network compatibility layers, we kind of need to be protocol aware of all of the different protocols. We can't have a, there we go, that's the end, sorry. I appreciate it, thank you everyone. That's Waldo right there too.